Hello, this is a video on median. I do also cover a little bit of mode and a little bit of stem and leaf. So there is that in this video in case you're curious. Median is a measure of central tendency. So it measures the center of your data. So if all your data listed out, it kind of gives you the middle. And that can kind of give you an idea of maybe what would be above your data and what would be below your data, but this is the middle. So it splits your data into 50% is on the lower half and 50% is on the upper half, okay? This table below, I usually would do this in a class and I would get the students' data so that they can relate to it, but since we're doing a video, I have the data for you. So in the left column, you see the sample number. And then in one column, you see hours of sleep and the hours of watching TV or YouTube or whatever, movies, anything like that. And I went ahead and put them in numerical order because it's just easier to read that way. That's a good habit for doing anything with median. Well, with median, you actually have to put the numbers in order. That's part of it. Because if you're splitting your data into the lower half and the upper half, then they need to be in order. So if you were to estimate just by looking at it, since it's in order, where the middle of the hours of sleep is, if you're just to kind of guess, it's not a grade, I'm not going to hold you to it, just guess, where do you think the middle would be? I'm kind of guessing here. If there's 11 items, then it's going to be somewhere around here in the middle, or if we're just kind of estimating based on, that's kind of the top half, that's kind of the bottom half. I would guess around 6 would be the middle. And then estimate the middle for the hour of watching. So again, we're just kind of guessing. I'm guessing it's going to be around the same area. So 1 hour. These are hours. So I'm going to label that. Labeling is always a good idea. And then what are some strategies to find the middle? I kind of talked about that a little bit. I noticed there were 11 items, so you could kind of split that in half. Or you can eyeball, size, like this looks like it's the top half and this looks like it's the bottom half. But in either case, you have to put the numbers in order. Zoom in on that. In order. And then eyeball the middle, or split the total samples, number of samples, in half. That would be a good way. And there might be some other ways that you were thinking about as you watch this video, and as long as it helps you find the middle, if you got somewhere around where I got, then you're good. So the number we're trying to estimate is called the median. It's the middle, kind of like the median in a road. It's the middle of the road. And to find the median, you always have to put the numbers in numerical order. So again, I talked about this in my video about mean. This is for quantitative data. So we're able to put these numbers, which is quantitative, quantities, we're able to put these numbers in order and find the median. And then that's the next step, find the middle. So how do we find the middle? We don't want to just guess. We want to have an exact answer. This is math we're talking about. There's 2 ways you can find the middle. One way is very simple. You can put your numbers in order and then start marking out numbers from the outsides and work your way towards the middle. Or there's a formula you can use. You use this formula, n plus 1 all divided by 2, where n represents the number of samples, we'll say. I was going to say items, which is fine, but I went with samples. And this value gives you not the median, but the position of the median. So please be careful of that. A lot of students do this formula and they're like, oh, I got 9, I'm done. That's not the median. And if you look at your data and 9 is not even in the data, then it can't be the median. That doesn't make sense. it gives you where the median is when your numbers are in order. And I'll show you an example. So median is a measure of central tendency. I've talked about this. It's the center. It splits the data exactly down the middle. Just for the sake of filling this out, we'll do that. So let's go down here and look at this example. We're going to do it 2 different ways so that you can see both ways and decide which one you feel like you like better. That's one thing I like about mathematics is there's not always just one way to do it, and that's how you have to do it. There's several ways, and whatever way makes sense to you in your mind, you should do it that way. Unless your teacher says you can't, and then don't. Okay, so we're finding the median. We need to put these in order. They are not in order, so let's see. The smallest number is 84, 88, 90. Actually, I'm going to mark these out as I go so I know I've used them. Especially in larger sets, and you're like, oh man, did I write that one already? I can't remember. Mark them out as you go, and that way you know you did it, it's done. Okay, so this method says mark them out from the outside. So I'm going to go these two, and that leaves 90 in the middle. The median is 90. Right smack dab in the middle. If you could picture folding it up, then 90 would be right there in the middle. Sorry, that was a horrible angle, but that's what I picture in my mind. And then the formula says n plus 1 over 2. N is how many samples there are, so 1, 2, 3, 4, 5. 5 plus 1 over 2, 6 over 2, is 3. Is 3 my median? No. Why would 3 not even make sense for the median? 3 is not even in our data set. So if 3 is not in the data set, then how can it be the middle? It's not. So use your reasoning, use your logic. 3 is not the median, it is the position of the median. So let's write these in order, just like we already did. We've already kind of done the work for it. 84, 88, 90, 95, 98. The third number is the median. Isn't that so neat? So you can see here that in either method, we get 90. So if you get the same answer doing it 2 different ways, then maybe it's okay to pick the method you like. I love math. Okay, here's another example. I'm doing 2 examples here because there's some different situations that you might come across as you do median that I want you to be prepared for. As long as you can logic and reason, then this would make sense to you. But just in case, I'll just show you just in case, so you're not scared if you come across it. We do have to put it in order, so I'm just going to go ahead and put it in order. Wow, we have some really spread out data here. 68, 74, 7. That looks like the smallest. 13 looks like the next. 15 looks like the next. 25. I always like when I have students with me because they can check. They'll say, no, Miss Brown, that's not the next number. You missed one. Oh, thanks. But I'm left on my own for these videos. I think 34 is the next one. 47. 59. We're running out of room a little bit. 68 and 74. I think I got them all. Let me just check. I learned from my last video and the mean video. I need to check myself. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers. Okay, so I got all the numbers. Now I'm going to use my first method where I just mark them out, starting on the outsides. I'm going to use some different colors so we don't get confused. Alternate here. You can actually mark them out if you want to. I just don't like to mark them out because then I can't see the numbers, so I'll just underline them. You could circle them if you want. All right, so here's the issue. This is the reason why I wanted to do this one. I'm left with 2 numbers here in the middle. So if I mark them both out, then there's nothing left. What can we do with these two numbers? I need to find the middle of those two numbers. So what's another measure of central tendency we could use to maybe find the average of these numbers? I'm giving you the answer. We're going to find the average. So we are going to take these two numbers and we're going to find the middle of those two numbers. So 28 plus 34, 28 plus 34, that's not very hard math, but just doing that. And then that's 31. So the middle of the middles is 31. Which makes sense because it is in the data set. And it's, if you think about a number line and you worked, your way in on a number line, then 31 is in the middle. Okay, let's use the formula. The formula is n plus 1 over 2. Another good habit in mathematics is not only do you need to make sure you're organized and you have enough space to work your problems, rewrite those formulas every time you need to use them. That way, when the test comes, you've written it so many times that now you know it. Okay, so I already mentioned that there were 10 numbers in this set, which if we divide that as 5.5, is 5.5 the median? By the way I'm asking, you probably know that no, it is not the median. Why can't it be the median? Let's look at these numbers. Why can it not be the median? Because it's not even in the set. So we know that 5.5 is not the median, it is the position of the median number. All right, so we put them in order. I've already done the work for that, so I'm just going to rewrite it. I'm rewriting it because I've marked all over it in my other problem that I don't want to use that again. I've already used it. Let me count and make sure. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I got all the numbers. So it is the 5.5 position, which is kind of not a position. 1, 2, 3, 4, 5, 6. So 5.5 means that it is in between those two numbers. So we still have to find the average of those two numbers, which we know is 31. That's it. That's all you do. There's two different ways to do the same problem, and you can pick. You don't have to do both ways every time. You just pick one and do it. I've talked about stem and leaf in my mean video, not like mean like you're mean to me, but mean like average. Stem and leaf plot is a nice way to see how data is distributed, so like the shape of it. In the last video, you can kind of tilt your head to the side and you can kind of trace the shape of it. The leaf is the right, I always get left and right mixed up. I don't know why. Most number, and the stem is the remaining numbers. So, for example, if we had 245, the leaf is 5 and the stem is 24. Or if we had 1,324, the leaf is 4 and the stem is 132. In this example, I just have two-digit numbers, so it's pretty easy to do. One is the stem, one is the leaf. And you'll notice that in my table, I only have 3 rows. So the 3 rows come from, I have 20s, oh, they're in order, that's really nice, 30s and 40s. So I have 20s, 30s, and 40s. And then you're going to put your leaves in order, and you're going to want to line them up evenly so that the shape is not distorted. So I have a 21, a 24, and a 25. I have a 30, yes, you have to write the 0. A 1, 31, 31, yes, you have to write it twice, and a 33. And then I have a 42 and a 45. You'll notice that these numbers are not the same. That's okay. It's just they have to line up pretty evenly so that you can see the shape. Actually, I did, whoops, sorry. The shape, whoop, goes like that. Okay? So you turn your head sideways to see the shape. And you can find the median by either, putting them in order, marking out, or you can just do, for this case, I'm going to do the formula. 1, 2, 3, 4, 5, 6, 7, 8, 9 numbers. 10 over 2 is 5. It's the fifth number. 1, 2, 3, 4, 5. The median is 31. Isn't that neat? That's kind of where the formula is nice when it's written like that. The mode is I haven't talked about this yet. Number that occurs most often. Mode is most, not the largest number, but the one that occurs most often. So look at this stem and leaf. Do any numbers repeat? 31 does. It's written twice. So the mode is also 31. There can be no mode, and there can be multiple modes. So beware of that as you work. That's all I have for this lesson. I hope you enjoyed it. If you have any questions, please email me or comment below, and I would be happy to help. Thanks for watching.